Hey everybody, welcome to video number 1 of this week, and in this video I'll be discussing the physiological responses that occur during resistance training. Now, I don't have a whole lot of weights and free weights at my disposal, so you'll have to just make do with the exercises in the video. Now, as I start off with marching in place, my muscles are preparing for the upcoming workload. Even before resistance exercise becomes challenging, my nervous system is already coordinating movement by activating the appropriate muscles. Now, one of the first adaptations to resistance training is actually neurological, not muscular. So when someone first begins a resistance training program, improvements in strength during the first several weeks are largely due to changes in the nervous system rather than increases in overall muscle size. Now, the nervous system becomes much more efficient at recruiting motor units, and a motor unit consists of a motor neuron and all of the muscle fibers it can control. As resistance exercise becomes more demanding, the body recruits additional motor units to produce greater amounts of force. Training also improves the synchronization of motor unit recruitment and allows muscle fibers to contract together more efficiently. And these neurological changes, explain why strength is often increases before noticeable muscle hypertrophy occurs. Now, we increased our workload here by transitioning into a bodyweight squat, and my muscles are going to require greater force production. As the demand of force increases, large motor units are recruited according to the size principle, meaning, smaller motor units that contain fatigue-resistant muscle fibers are activated first, and as the exercise becomes more difficult, progressively larger motor units are recruited to meet the increasing force requirements. The recruitment pattern allows the body to produce only the amount of force necessary for the activity while maintaining efficiency. And resistance training also places a greater demand on the ATP-PC system and anaerobic glycolysis because these energy systems provide ATP rapidly during short-duration, high-force activities. Another important acute response is an increase in heart rate and blood pressure during resistance exercises. These cardiovascular responses help deliver oxygen and nutrients to the working muscles while removing metabolic byproducts produced during contraction. And although resistance exercise does not rely primarily on aerobic metabolism, the cardiovascular system will play an important role. And you'll see here I'm transitioning into my recovery period. Again, I'm kind of limited with my space, so I'm just kind of walking in circles. But my heart rate will gradually decrease, and my muscles will begin restoring ATP and my phosphocreatine stores. Now, recovery is a huge important part of resistance training because many adaptations to exercise occur after the workload is ended. And then repeated exposure to resistance exercise stimulates the nervous system to become more efficient, thus preparing the body for future training sessions. So just to kind of recap here, the earliest adaptations to resistance training occur within the nervous system, and these acute physiological responses allow the body to gradually adapt to increasing resistance while improving overall force production and exercise performance.